Okay, so I have a board, and I want to generate all child positions. Also, I have a board and I want to generate all parent positions. And it does matter whose move it is. Because then other pieces will move. I think I would. I want to use an array instead of a vector to avoid having to allocate memory all the time and free it again. Then that array must be large enough to contain every child and or parent position, for which probably there are positions where the kings are far apart, so they will never far apart and far from the edge. So each king can always move to wherever. The rook is also not stopping them. In those positions, each king has 8 possible moves, and the rook has the width of the board plus the height of the board, the number of moves, -1 for each. So -2, I guess. And shall I store that in size or in board? I think I store it in board, because the reason for using the size object is that certain things need to be known. Without that, we are able to include board.h. But I passed that point now. Because that info might also just include board. So say size was actually part of board, then that would not be a problem for this one. Or would it? No, of course not. Board is not included at all here though, but yeah, the question is who is including info. Graphs including info. Well, yeah, that can be done after board is defined already. Then we have block index. Maybe the only reason it can go wrong is when board uses block index. In that case, I could not first include board. Maybe have a look at board to see what it now exactly uses. It does not use anything except color, which is completely standalone, and square. Oh, seriously. Okay, but that includes these three. And that includes king square. And square compact. Wrong version. Could put this in the .cxx file. Certain clauses need to be defined before board is defined. Board uses black king square, white king square, and white rook square. White rook square uses square compact, therefore square compact must be possible to be defined without having board. And it seems to be the case that except for this. I mean, if size would be part of board, then. So that would not really be a problem then, or what? Yeah, because it is not using it. Right, okay. Oh, but this is. Yeah, it is indirectly. Size board must be passed. So for this reason, we cannot put size into the members of size cannot be put into board, because we can't include board before we define this thing, and it requires that stuff. However, any class that I'm going to define from this point forward can have board included, because board is now completely defined. And I think that it might be beneficial if I move as much to board as possible from size. So that now the question is then, which thing in size does not really need to be in there for the definition of board? So this is the definition of the board, basically the size of a block, the number of partitions. So block and board were necessary, I think, and therefore the board size is necessary. But these things, I'm not even using them yet. I can comment this out a bit. Probably not, but that is in info. Okay, let's instead then move it to apply type depends on. Depends on ply bits, which is max ply estimate, which is not depending on anything apparently. Yeah, I think I can like move everything to, well, not everything, but everything below this. These four and what I commented out can all be moved to board. I think I should do that. I'm just going to try it. Here I already have it. Aha, maximum number of, yeah. This is the number of rook moves. This -2 is the maximum number of rook moves. And then +8 for the king, and then the -2 again. Right. Okay, so having moved that, definitely have to move this now. Well, at least this one. Gonna move all of them. It's not even used yet, seriously. Then I delete it. For now. To be part of info. No, info just has the classification. So there's no need to have a classification type here. It's not really an estimate, it is just the maximum. No, okay. I think it works. But this can also be a parent, so it's a maximum number of children or the maximum number of parents, actually both. So I don't want to use the word children here. Thought I had the ChatGPT open as well. One, two, three, four, five. I need 5 AIs. I don't trust Gemini. So maybe it's not. I'm gonna ask DeepSeek. I'll use this one. Connections maybe. Yeah, I think neighbors is the best. Degree is a graph theory term with a number of edges connected to a node. Oh, that's also nice then. Okay, I'll use a degree. Okay. So hardly needs to be part of board. I think this is the most complex, sorry, the most compact way to store the actual number of children, which has to be stored both as the actual number of children, as well as the number of children that did already visit the parent so far. So it's not even max degree, it's really just a degree type. But I'm explicitly using it for children, really. So yeah, I'll keep calling it degree, but it's not degree. So I have a degree type then, aka number of children type. And I don't need to define that here because I'm only using it in info. So now we're moving stuff from board to info. So let's look at info. Yeah, here the max degree. The number of legal positions that can be reached from this position. So that is simply to the number of children. Just instead of max degree underscore, I should really use number of children. And the type is then just degree type. Yeah, who's using this supply type? Also info. Let's move both. Okay, so let's add a new function here that returns I'm gonna use neighbors now, I think. And we're going to put the neighbors in neighbors type. reference neighbors out. And I need to tell it whose move it is. So color to move. So given the current position, this is a board class, and if I call this, it's going to fill in all the neighbors of the current board, assuming that the color is to move is to move. But then I also need to tell it which type of neighbors. So that's the neighbor type. Oh shit. Oh shit. Now I need, this is part of board. So yeah, I do need to know the max degree because it's a part of the type of what I pass to a member of board. For that reason, max degree is a part of board and I have to move it back. Now this can go to the top. Let's put it higher, I mean with the other using stuff. But usually I'll be using only one. Well, using. And then info.h, board.h. So I need to know in board what is the max degree. Just move that, only that. It's already fixed. It should return the number of neighbors that is added to neighbors out. Not sure if this is going to look inboard for the neighbor, you know, and that one. I thought that you don't have to add that. You don't have to add a board prefix here, but you would have to do it for the return type. Yep, that's correct. Okay. Well, and finally it gets interesting. What is an efficient way? I think the most efficient way is to pre-calculate as much as possible and then generate all the moves based on the pre-calculations. And I need probably very a specialized code, so I'm totally going to split up the part where we do king moves and the rook moves. Let's begin with king moves, which would be sufficient for when black is to move. So, independent of the value of to move, well, not entirely, because I have to move the right king, but the logic is the same. I get a section that is generates king moves. And have a return type that counts a number of neighbors. To return. And then if I found a new neighbor, then we're gonna do neighbors plus plus is neighbor. Where a neighbor then must be a board. But I would prefer to work with just the underlying integral value here instead of with the class itself, with the board class itself. Neighbors out stores and there's an array of board. And the board itself has an encoded type. So I want to work with encoded type. And then I want to store the encoded type in the array. And that means I have to probably just construct it. No, it's already constructed. I want to be able to unsign to a board. That's exactly what I want. Just add it here. So I'm gonna have a board reference operator assign from the encoded type. And then we set encoded to encoded. And we return this. Although, well, that's how you do an assignment operator. Hopefully the compiler will throw this away because it's one in line 2. I'll never use the return value. So basically it's just an assignment. And then internally I'm going to work with this. So I'm gonna have encoded type neighbor, and now we can assign it to a board. So this is gonna work. Except that now, of course, we need to generate. Okay, we begin with setting neighbor to encoded, which is the current board, because we are inside board. So now nothing moved. If I add this, then that is a null move. So in between here, we need a loop as well, which runs over all 8 allowed king moves. And there's 2 problems here. One of the problems is finding out which are allowed. And that's kind of annoying. Difficult. Yeah, let's look at some preparation work. let's have an array with king moves, king offsets, king move offsets. Which I'm going to store encoded type, and there's of course 8 of them. And I want to have this filled during compile time. Is that possible? It's probably for the best. I have 2 types of offsets. One that we can add and one that we can subtract. Because depending on if the king is on the edge of the board, we can't add or we can't subtract. So we have to pick one of them. Let's begin with add offsets. And then it depends on the color. If I want to do this as a cons expression, I think I do. So this must be a cons expression. Of add offsets. And the color, okay. Let's say black add offsets. I'm gonna generate them like this. We have a king here. King. Let's just generate a 0, 1, 2, 3, 4, 5, 6, 7. Maybe there's a better order, but can always change it. Now I think about it, let's count it like this: 0, 1, 2, 3, 4, 5, 6, 7. Again, probably the easiest way to construct this thing is doing x and y coordinates separately. And so I need a -1 and a +1 for both x and y. Let's just use encoded type. Maybe I should use int, fast int. That's cons expression anyway. It's gonna end up in an encoded type. doesn't really matter what I use here, but okay, let's use encoded type. Delta x minus 1. And then delta x 0. Plus 1. And then again for the y coordinates. Okay, now how is the king stored? I have a lot of cons expressions. Maybe I should just... Can I construct a black king square from this? Not really, not with the negative values. How do you subtract 1 by adding? I mean, these bits are somewhere in the middle of an unsigned integral. So I'm gonna have to assume that you have a positive value. So we have some bits that we don't want to test, don't want to touch. So b b b b b, and then I have say a small. No. I have something that is in the middle. Let's say these are the bits that describe the x coordinate. And these are the y coordinates, they're the same. And then we have a few other bits. And I think the x coordinate is actually the least significant one. So, and this is the x coordinate. Now, adding one is easy. You just add. You just add this, right? So that would overflow if this is all ones. 1, 1, 1, 1, 1. But if that's the case, then I'm not going to do the add. I'm going to use the array that subtracts. That makes sense. So in this case, I'm going to assume that if I add 1, there is no overflow. But hey, we have a problem then if it is all zeros. Any edge is a problem. Yeah, you have to switch between adding and subtracting, even as function of the deltas themselves. Ouch. Those are special cases. Of course, the number of times that the king is at the edge is very small. So I could test that first, and then the bulk of the code is going to execute while not being near the edge, and therefore there is no problem. I can add or subtract whatever I want. It's simply not possible to subtract 1 without an overflow if I add. If I want to subtract 1 from this by adding, I have to add 1, 1, 1, 1, 1, 1, 1, which then always gives me an overflow here. So that means that I would have to you could, if I add all ones and then get an overflow, and then I can just always get an overflow. Might as well fill all these with ones, and then the overflow is pushed to the B, and then fill these with ones. In other words, just from all the way here, all ones. Then if this is not 0, and it should not be 0, because you cannot subtract 1 from 0, then we step off the board. So that gives an overflow, which means that none of these bits are changed. That should just work. And I can generate that with all ones by subtracting that all zeros and the single one from all zeros. So I think I'm going to start with the plus ones. Delta x0 is just 0. Don't even need that. Also here, if it's a const expression, it just depends on if black is to move. Maybe you have to separate it out into different functions. Get the neighbors with black to move hard-coded in the name. Although it's exactly the same, except for shift. No, not really the same. It's only the same for the king neighbors. Okay, I'm gonna make a new member function that just adds the king moves. And that will be a template that takes a to move as a template parameter. I'll have to move that in board.h, but well, let's code it here. So I have a template. I don't think I can use a color. I'm just going to use the wrapper to wrap the value. Color type, which is an enum, so that should work. And then I want to define these things. Still the same. Damn it. Okay, though this would be in board. The black king, which is stored here. And the black king square itself is stored as a king square, which is, oh boy god, oh, I had not anticipated this. Yeah, that's true. They have a block index as well, that changes. Arg. So if the king steps from one block into another block, then we have a problem. Yeah, this is stupid. The encoding is not that trivial. If you're on the edge of a block even. It's only 8 moves. Maybe it is easier to not do it as a const expression. Simply do a loop and extract the coordinates themselves. Or So the stuff depends on a lot of special cases, really. So the color, who's to move, and if it is at the edge of a block, and then it depends if the block is at the edge of the board, and or on the edge of another block. But okay, that's a boolean. But finally, the king could be in a corner of the block, which is then again a special case. And then all the four corners are a different case. So all the four edges are different case. The corners are different case. So that's already 8 possibilities within one block. 9 actually, because you can also be in the center. And then each edge is the 2 possibilities. Either it's a real edge or not. And then in the corner it could be, of course, one of 4 possibilities. So it's like 4 times 4 plus 2 times 4 plus 1. And then the whole thing times 2 again, because it depends on which color is to move. Is it worth it? No, I'm still not done, if you ask me, because then I have to take into account if yeah, it's just horror. It is not trivial. Yeah, let's not do this, because I'm just wasting, no, not wasting time, but it would probably take me weeks, and then we don't even know if it is necessary for speed. Maybe I should just code it in a way that it works, even though it's 10 times slower. Because it's not easy. 2, I'm not even sure if it gets significantly faster if I would do this. I was trying to get it as branchless as possible, so let the CPU run and not have any branches, but yeah. Too bad. Okay, I'm gonna try to still keep this function maybe, but think I should extract coordinates and then do it everything in the runtime, and then we'll have a lot of tests. And a lot of shifts and a lot of bitwise ends and ors. Ugh. So only thinking, is there not a way to be smart about it, or? Yeah, come on, man. I can just test if it is 0, right? If this is 0, then we do not want to subtract. We do not want to subtract 1 from delta x. So from x, I mean. And if it is all 1s, or whatever the value is for the maximum possible value on the other side of the edge, that would be for the rook. I still have the block thing. And okay, in this case I don't want to add 1. Maybe I can just make 2 booleans to test that. Okay, still going to try it. First thing is cons expression, encoded type, x coordinates, mask. That is something to do with king square, I think. Mask. There's both coordinates. Yeah, x coordinates. Oh yeah, like that. I was forgetting again that we have a block index. There's really no way to do this fast. I don't think it is. I don't think there is. It would be a fast way to check if we are at the block edge. Then I could do slow code only when the king is at the block edge, and super fast code when we are in the middle of a block somewhere. Yeah, it's so much more complex, even in the middle of the block. You have to detect if you get next to the other king, and black has to check if it is in check or not. Okay, yeah, forget it. I'm gonna do everything the slow way, so... I am going to split things up though, then in by type. It's not a very nice way to do this. Maybe I should do it differently. Unfortunately, it compiles, so that makes me less motivated. still the feeling that it is faster to do it as branchless as possible in the inner loop. And if you have code like this, where the variables, all the variables are independent, then it's executed in parallel anyway. I think these two lines together take 1 clock cycle or something like that. This is CPU horrible. It's well, it's, let's see what it exactly does. Yeah, it's pretty horrible. That's this one. That calls xy to block index and xy to block square, and then passes that to both, to blocks index square to coordinates. Okay, xy to block index is constructing a block index, which internally calls xy to index, which is a fucking fission. Division. 2 divisions. It's so horrible, this. But okay, these are const expressions. So if I make this a power of 2, then the compiler will change the division into a modulo, or a, not a modulo, but a shift. Yeah. So make everything a power of 2, then the division drops out. I think the multiplication can also turn into a shift, but I guess multiplication is should be as fast as a shift. 1 clock cycle, I guess. And then we have so these are already 4 divisions and 2 multiplications, and then this is called, which is doing another shift and an OR. So I really should not be concerned with extra CPU here. Clock cycles here less, more or less. This is also again a shift and OR. 2 shifts, an AND and an OR. And I would almost use modulo here to convert this to dx. I'm not gonna do that, right? Let's use a table here. And if it is a table anyway, I might as well remove the 0, 0 here. I had it in because I always thought I was going to use modulo. And since I'm just gonna turn this around again because that's how it's put in the array. So now these things just match here. The -1 is in index 5. Yeah, these days you can leave the comma here. It's gonna ignore that. But I'm an old-timer, so I don't like to see that. Okay, let's see. In fact, you don't have to fill an array completely. If you just stop somewhere, then the rest is filled to zeros. And let's see. Or default constructed, whatever. In this case, we have a standard pair of 2 ints. Whoops. So the auto should make this a standard pair again, but then by name. So dx and dy is directly the ones and the minuses here. Type int. And then, yeah, add that, and then we have our x and y, which we then set the king square with, at least here. And now the problem is that if we are at the edge, then x and or y becomes a negative. Or we go over the edge of the board on the positive side. I mean, these become negative. No, the dx become negative. Dx, dy become negative. These should be clamped. But I feel like maybe I can avoid doing 4 tests here. But how? I mean, the top and bottom, you know, now you still end up with 8 different cases. I feel like doing those tests. I mean, there are like a lot of tests, but I can do those tests before the loop, gaining a factor of 8 speed up, right? And then just pick a different array, depending on all the special cases that we have. But those are then left edge, right edge, and then vertical and horizontal. So you can either, there's 3 possibilities per direction. It's either on the left edge, or you are in the middle, or you're on the right edge. And then independent of that, at the bottom or in the middle or the top edge. And that is 3 times 3 is 9 different possibilities. And having chosen that array, that array has different sizes then. And therefore it has a different type. But I can separate out the the size and the type maybe, so that to define all types the same. Give them all, make all the arrays size of 8, but only fill a few of the elements. The rest is then 0. And then I have to loop till the actual number of elements. So we need the size as well then. But I could put that in the same array. Not if you have a standard pair. Well, good. Or I think if I put that there, no, that wouldn't work. Or would it work? The array still needs a name. Oh, dx, dy. So this can be a const expression. You can use the same encoding for the where we are on the board. So if you are this edge here, then it's a 0. Sorry, then we are in the corner. I need to find out what that is then. It's also possible that if we are near the other king, that just one thing drops out. Well, one being a corner, or a corner and something that is next to it, or two corners and everything in between. So that is a 1, 2, 3, 4, 5 possibilities per edge, 20 possibilities, depending on where the other king is. And if we are black, then the rook could cut off one thing, but it's the same as an edge or the king. But the rook can also cut through like this. So we are in check, and then we're not allowed to walk towards the rook or away from the rook. It's never just one thing, of course. I mean, the white king is blocking the rook, or it isn't, and if it isn't, then both are attacked. The rook is here. Still, the white king could be in the middle, but okay. So we had 20 possibilities, 21, and then vertically is 22 possibilities. No, it's worse than that. The rook can be combined with the edge and or with the king. Yeah, it's too much. I'm not gonna do an 8 factorial, as it were. Well, 2 to the power 8 ish number of arrays, am I? Probably should write a program to generate this code. And then he could do it. Okay, I'm gonna stop for now because other stuff. Let me read the chat if there is any chat. Hi, Aman. Yeah, sorry I wasn't watching at the chat because I wanted to concentrate. Okay, 0 views. Yeah, I'll be back later.